So, hello everyone, my name is Jian Zhou. The project I did this semester is a software-defined networking for data center. As data center technology evolves, data and application have been better connected. Newer and better achievement have been enabled with the deployment of virtualization. Intelligent information technology, such as artificial intelligence, becomes more and more popular. The network infrastructure lays the foundation for all the enablement to the new era of intelligent information technology. The network infrastructure needs to be designed for workload, application, and data, along with easier deployment and daily management to provide agility, flexibility, and reliability to meet the business need. Software-defined network for data center centralize the management with the optimization of the application lifecycle and the flexibility of application provisioning. In this presentation, we're going to compare the software-defined networking for data center with the traditional data center network to derive the advanced features and advantages of software-defined networking for data center. We will also go through some demonstrations of software-defined networking for data center to illustrate the improvement of productivity and the reduction of operating cost. Data center network as the earliest application of software defining enables the implementation of public cloud. Imagine a situation without the software-defined network as the data center infrastructure. It may take days to months between the order has been placed and the production in the public cloud. With the software-defined feature for data center, after the order has been placed in the public cloud, the scripts will be pushed to the target, and virtual machine, virtual local area network, VLAN, VXLAN, routing, firewalls can be created and provisioned in seconds, as well as IP addresses and policies being properly allocated and assigned. Software-defined network for data center is a ready demand or inelastic demand. It provides tremendous business value for enterprise. It is important to understand how the concept of software-defined network derived from the traditional network. Switches are the fundamental elements that form the data center network. The traditional switch architecture can be considered as three separate planes. Management plan of a switch refers to the functions and features related to the management, such as a very common and classic way to manage and configure the switch, which is called Command Line Interface, CLI. This defines the way in which the administrators and engineers can manage the network device in the network infrastructure. Control plane of a switch is the communication between the switches to ensure the exchange of the information such as the reachability states so that the switches share a consistent data delivering enablement. Data plane of a switch is the actual movement of the data in the network from the source to the destination. The network infrastructure formed by the network switches ensures the efficient and accurate delivery of the data. Software-defined network is to abstract the control and management planes from each individual network switch to a single point called controller. It brings the cloud-like experience to the enterprise network, which is the automation, centralized management, and fast provisioning. It also eliminates the issue caused by human error in traditional network due to the isolated management and the huge amount of manual configuration. Cisco is the leader in the network technology industry and dominates the network market since the very beginning. The Cisco software-defined network solution for data center is called application-centric infrastructure, ACI. It unifies the automation and management of the network switches, which are also called fabrics in the data center network. The controller, which is also known as Application Policy Infrastructure Controller, APAC, provides centralized access to all fabric information, optimizes the application lifecycle for scale and performance, supporting flexible application provisioning across physical and virtual resources. Simple initial setup is not necessarily a requirement for software-defined network. However, the easy initial setup is always an attractive point to the engineers. Normally, a minimum of 3 controllers, which are also called APEX, are needed to ensure the high availability by eliminating any single point of failure. It is recommended to connect them to different switches to form the best practice of redundancy. The 3 APEX will form a cluster for single management. The state and information will be synchronized among the APEX. There are 2 kinds of switches in the typical ACI solution: span switches and leaf switches. The span switches are acting as the aggregation layer. Those switches are connecting to the leaf switch and are only connecting to the leaf switches. It is recommended to have 2 span switches to achieve the redundancy. As most switch model for span are chassis switches, there will be enough port to connect the leaf switches. The leaf switches are uplinked to the span switches. The leaf switches are responsible for connecting all kinds of endpoints, such as servers and storage, and forming external connections, such as the connection to a network gateway. Based upon this concept, the APEX are connected to the leaf switches. Another thing to consider ensuring the high availability is the redundancy of the physical hardware accessories. The power supplies, fans, uplink ports, supervisor modules should be designed and implemented as pairs or multiple to eliminate the single point of failure. Once the physical installation is done, everything is connected and powered on. The APEX will start automatically discovering the switch. First, they will discover the switch that are directly connected with them. After the directly connect switch, which is also called a leaf switch, is discovered and registered to the APEX will discover the other switch directly connect to this leaf switch. Let me pause here and show a short demo of this while I'm continuing introduce the function and features. So those switches will be the span switches. The span switch will go through the same process to register the APEX. After this, the discovery process will continue with the directly connected switch to the span switch will be the rest part of the network. This process allows the APEX to discover and register the entire ACI site topology automatically. As we can see in the video, this is the discovery process and the register process. As the discovery process is considered as three steps, each node in the network is 3 hops away from each other. After the discovery is done, the APEX will automatically configure the underlay network to enable the communication between all the network devices. The menu here shows the basic initial setup after logging to APEX using a web browser. These steps need to be followed as the sequence from the top to the bottom. The first of them is to enroll the switch, which we just did. After this, the basic information for BGP routing will be entered to ensure the underlay routing of the network. The third step is to set up the out-of-band management. The fourth step is to set up a domain name server. The fifth step is to set up NTP, network time protocol. The last step is to review and confirm all the information entered above. After this initialization is done, the software-defined network data center network is ready to be used, as we can see here. And Let's see. So those are all the devices in the network, and we can also see the topology map in the ACI solution. As we can see here, we have two span switches and two leaf switches and three APAC server. Continue. So the modular interface configuration of the ACI solution enables the creation of policy sets to link the different features and parameters to the interfaces. Comparing to the traditional network, the modular configuration utilizes the templates to largely reduce the amount of configuration work efforts and eliminate the chance of human error. Instead of memorizing the commands and configuring each interface on each network switch separately, the predefined policy can be named with easy-to-understand labels and applied to any interface on any switch whenever needed. As the virtualization of the server is the most popular solution nowadays, Cisco ACI solution provides the support of hypervisors from multiple vendors. When the VMware vSphere distributed switch is integrated with Cisco ACI, the monitoring and the configuration of the VM networking is enabled from the APAC. As shown in the snapshot, some basic information is needed to connect and authenticate the ACI solution with vSphere virtualization environment. Since the time is limited, I'm going to show all the demo in the end. The trend of the next generation software-defined network requires the enablement of multi-tenant solution. It is the logical separation in the network for different tenants, such as different companies or the different business units in a company. Even all the computing and storage nodes are connected into the same network. The access and the resource allocation are accurately divided as needed. In addition, the statistics and the monitoring enable the administrator to provide the detail of the utilization of each tenant. It is very useful information in the business operation, such as budget allocation, expenditure sharing, and so on. The ACI solution also supports multi-layers of tenant solution. For example, a network has been shared by multiple companies, and each company has multiple business units. Each company needs its own dedicated network resource, and the separation and isolation from each other. Each business unit in each company also needs its own dedicated network resource and separation. In such condition, different tenants can be defined for different company in ACI solution. And under each tenant created in APAC, virtual routing and forwarding VRF instance can be utilized to provide the separation and isolation for each business unit. As the multi-tenant environment has been built, it is now the time to define the proper access privilege for certain resources on the network. Cisco ACI solution utilizes a concept of contracts to provide a way for traffic flow controlling within the ACI fabric between the endpoints. Those contracts are created and defined using a provider-consumer model where one endpoint group provides the service it wants to offer and another endpoint group consumes them. The contracts enable the flexible application to different predefined network groups. So here is the contract GUI. We can define the contract from here. We're going to talk about the benefit of the software-defined network for data center. The mass production of the hardware enables the adoption of lower cost to produce the good quality switch to meet the traditional data centers requirement, such as non-blocking switch, line rate speed, enough per port buffer, low latency, and so on. As a result, even though those parameters of the data center network switches, such as non-block switching, line rate speeding, are still important to ensure the network performance, they are no longer the core competency of the data center solution. The core competency of the data center solution is the efficiency brought by software-defined. It brings the public cloud-like experience to the enterprise network, which is the automation and the centralized management. It solves the issue caused by human error in traditional network due to isolation configuration and management. Software-defined network solution also enables big data analysis and artificial intelligence to support continuous predictive optimization of the network. It is the intelligence of the next generation of the network. Instead of manually configuring everything and troubleshooting, we tell the network what we want to achieve. The network understands our intent and performs corresponding tasks, monitors, and analyzes the expected outcomes. It also continuously optimizes the network to enhance the performance and prevent potential issues from happening. The software-defined data center network solution is the trend of the network industry. As the modern businesses are shifting towards the business unit model, the multi-tenant enablement of the software-defined network will provide more value. The software-defined data center network solution helps companies improve the productivity by making the process of new applications deployment much quicker. It also helps companies reduce the operating expense by eliminating the complexity of the configuration and management. In addition, with the software-defined network, a better recovery time objectives and recovery point objectives, RTO and RPO, can be achieved as the backup capability brought by the software. The further development and the wide adoption of software-defined data center network solution can be forecast. It is a great pleasure learning with all of you in this class and collaborating in the Blackboard discussion forums, especially during this hard time as COVID-19 disrupts our normal way of working and study. I think we're really doing a great job through the hybrid learning method and enjoying the full benefit of it, including the flexibility, high efficiency, and collaboration through the available